Hello student, today I will discuss about the gravitational potential. Gravitational potential. Gravitational potential. And its expression. आज हम ग्रेविटेशनल पोटेंशियल और उसके फॉर्मूला यानी एक्सप्रेशन डिराइव करें. व्हाट डू यू मीन बाय द ग्रेविटेशनल पोटेंशियल? क्लियर? Gravitational potential at a point in the gravitational field is the amount of the work done to bring a unit mass from infinity to that point. किसी ग्रेविटेशनल फील्ड के अंदर किसी बिंदु पर ग्रेविटेशनल पोटेंशियल किसे कहते हैं? The amount of the work done to bring a unit mass from infinity to that point of gravitational field. एक यूनिट मास को इन्फिनिटिव से उस ग्रेविटेशनल फील्ड के उस बिंदु तक लाने में जो टोटल वर्क डन होता है, उसी वर्क डन को उस पॉइंट पर ग्रेविटेशनल पोटेंशियल कहते हैं. Is it clear? Gravitational potential at a point in gravitational field is the amount of work done to bring a unit mass from infinity to that point. Clear? इसी को हम ग्रेविटेशनल पोटेंशियल कहते हैं. इट इज डिनोटेड बाय भी. इसे भी से हम डिनोट करते हैं. एक्सप्रेशन फॉर gravitational potential. Clear? Suppose that this is an isolated mass. यह कोई isolated mass है of mass m producing the gravitational field. O is the center. From center O at distance r there is a point there is a point. This is P. कोई आइसोलेटेड मास है. दिस इज एन आइसोलेटेड मास. Isolated body. Suppose that there is an isolated body of mass m producing the gravitational field, जो अपने इर्द गिर्द ग्रेविटेशनल फील्ड प्रोड्यूस करता है. A point P is situated at a distance r from the center of the isolated body, at which we have to find the gravitational potential. Suppose that there is another point A. Lies at a distance, यह पॉइंट ए है जो सेंटर से, कहां से, सेंटर ऑफ आइसोलेटेड बॉडी से एक्स डिस्टेंस पर है. इट क्लियर? नाउ सपोज a point A is situated at distance x from the center of the isolated body whose mass is m. So, according to the Newton's gravitational law, the force unit mass is here, m बराबर 1, कोई बॉडी है. Suppose that the unit mass is placed at point A. So, according to the gravitational law, force of attraction between the mass of body and this mass, F is equal to G M, और मास या m बराबर यूनिट मास है तो इंटू 1 बाई एक्स स्क्वायर. तो दैट इज F is equal to Gm by x square. This is my equation first. Now this body is moved. This unit mass moved from point A to B through a distance dx. Now we move the test mass or the unit mass of body from point A to B through a distance dx. So there is some work done. There is some work done. So work done. There is a small work done is the dw. Now a dw work is done in moving the unit mass from body A to point B. Point A to B through dx. Distance dx. So the work done dw is equal to F into dx. मान लिया कि स्मॉल वर्क डन dw है तो dw बराबर F into dx. तो dw is equal to F is from equation first Gm by x square into dx. Clear? This is the. Now we have to find out the total work done to bring the unit mass from infinitive to the point P. We have to calculate the total work done to bring this unit mass from infinitive to point P, and it can be obtained by integrating this equation. So we can integrating this equation dw बराबर gm by x square into dx. Now we have put the limit. This is the 0 to w and this is infinitive to r. At distance r, यह जो है OP जो है कि यहाँ पर है r डिस्टेंस पर है. तब क्या हो जाएगा? W is equal to integration. तो gm is the constant, taking the gm outside, या r हो गया, infinitive हो गया 1 by x square into dx बराबर gm इंटीग्रेशन r infinitive gm into x का पावर -2 into dx. तो W इक्वल टू क्या होगा, GM, इसका क्या होगा, -2 + 1 बाई -2 + 1 R इंफिनिटी। तो वैल्यू क्या आया, GM x का पावर -1 बाई -1 इक्वल टू R इंफिनिटी। ठीक है, यहां हो गया R और ये इंफिनिटी। वी कैन अपर लिमिट माइनस लोअर लिमिट, इस माइनस को हम बाहर कर लें तो ये हो गया W इक्वल टू -GM और ये हो गया 1/x R इंफिनिटी। तो -GM 1/R माइनस 1/infinitive, 1/infinitive इक्वल टू 0, so this equation becomes -GM/R. The work, by the definition, the total work done W equal to -GM/R. This is the total work done. So by the definition, the total work done to bring the unit mass from infinitive to a point of gravitational field of an isolated body is called gravitational potential. Then the W equal to V, इसलिए V equal to -GM/R. Is clear? तो ग्रेविटेशनल पोटेंशियल इज द -GM/R. Is it clear? No doubt. Negative sign indicates the work done by the gravitational field, not against the gravitational field. Negative sign indicate the work done by the gravitational field, not against the gravitational field. यह जो है वर्क जो किया जाता है यह ग्रेविटेशनल फील्ड के द्वारा होता है, ग्रेविटेशनल फील्ड के अगेंस्ट नहीं होता। यदि ग्रेविटेशनल फील्ड के अगेंस्ट होता तब यह साइन क्या होता, पॉजिटिव होता। नाउ वी फाइंड आउट द ग्रेविटेशनल पोटेंशियल एनर्जी। ग्रेविटेशनल पोटेंशियल एनर्जी, we have to find out the gravitational potential energy. Expression for gravitational पोटेंशियल एनर्जी। ठीक है, सपोज दैट ए बॉडी ऑफ मास m, it is an isolated body which producing the gravitational field. A point P lie in the gravitational field from the center of body, center O of isolated body at distance R. R distance पर कोई point है। Suppose that a body of mass m is placed at point P, at which we have to find out the gravitational potential energy. As we proceed in the previous, Similarly, we proceed. So gravitational potential according to the Newton's gravitational law. So the force of attraction, gravitational force between two, that is the isolated body and a body of mass m, is given by gmm by r square. Is it clear? gmm by, sorry, now we consider a point A at distance x from the center of isolated body, at which the body of mass m is placed. We consider a point A at distance x from the center of isolated body of mass m. Suppose that a body of mass small m is placed here. So according to the Newton's gravitational law, F is equal to gm m by x square. This is my first equation. Now we move the body mass m to point B, through a distance dx. So we have to do some work. हमें कुछ कार्य करना होगा. If we move the body of mass m from point A to point B, suppose that the dw is the work done, that small work done, and that small work done is given by F into dx. So F is given gmm by x square into dx. Clear? So dw is equal to gmm by x square into dx. This is the second. Now we have to calculate the total work done. If we brought this body of mass m from infinity to point P in gravitational field, we can obtain the total work done by integrating this equation within the proper limit. So we have to integrating within the proper limit. dw is equal to integration upper limit is the infinitive, lower limit infinitive, upper r gm m by x square into dx. So now it becomes w is equal to gmm is the constant, gmm constant हो गया, इसको बाहर करना है तो r infinitive 1 by x square into dx. Clear? We may write gmm integration r infinitive x का power minus 2 into dx. So w is equal to gmm x का power minus 2 plus 1 by minus 2 plus 1 r infinity. तो माइनस 1 हो गया, इसको बाहर लेना है तो माइनस gmm, तो ये हो गया इसी, तो x का पावर minus 1 r infinity. तो w is equal to 1 by x हो जाएगा माइनस gmm by, sorry, not by, 1 by x r infinitive. We can put it minus gmm 1 by r minus 1 by infinity. 1 by infinity बराबर 0, इसलिए w is equal to minus gmm by R हो गया. This is the total work done to bring the a body of mass m from infinitive to point P. ठीक है. बॉडी P को, बॉडी M को इंफिनिटिव से P तक लाने में टोटल किया गया कार्य. एंड दिस वर्क डन शुड बी इक्वल टू द एनर्जी. जो वर्क किया जाता है वो कहाँ जाता है? इट इज स्टोर इन द फॉर्म ऑफ द एनर्जी इज दैट बॉडी, एंड दैट एनर्जी इज कॉल्ड पोटेंशियल एनर्जी. इट इज डिनोटेड बाई U इक्वल टू माइनस GMM बाई R. माइनस GMM बाई R. We may write this is the gravitational potential energy. We may write U equal to minus GM by R into R. Sorry, M. We recall memory in the previous. GM bar R equal to potential at point P. M is the mass. So equal to minus gravitational potential, gravitational potential into mass of body. Clear? So gravitational potential energy is equal to gravitational potential into mass of the body. Is clear? This is the gravitational potential energy. Now we talk about what is the variation in potential energy if the body brought to a certain height above the earth's surface. Above the earth's surface. Gravitational potential energy above the earth surface at height h. ठीक है. On the earth surface हमने क्या किया? फ्रॉम द सेंटर ऑफ द बॉडी हमने अभी जो डिराइव किया U इक्वल टू माइनस GMM बाई R. क्लियर? नाउ this is the R is the distance of the body from the center of isolated body which producing the gravitational field. Here Earth is the isolated body of mass M producing the gravitational field. So R becomes capital R. If a body placed on the earth surface, then the R is equal to capital R. यहाँ R क्या हो जाएगा? Capital R. R is the radius of the earth. So if they above the height, so the distance of the body U is equal to minus GMM by R plus H. Clear? R plus H. Now we may write minus GMM R common लेने तो 1 by H by R. Is it clear? We may write as minus GMM by R into 1 plus H by R minus 1. we can break it by using the binomial theorem. Since h by r is very small, that is less than 1, एक से बहुत बहुत छोटा है. So the higher power of the h by r, higher power of h by r may neglected, तब हमारा इक्वेशन क्या आ जाएगा, u इक्वल टू माइनस जी एम एम बाई आर इंटू 1 माइनस एच बाई आर. इट क्लियर? नाउ वी solve it. Minus gmm by r plus gmm h by r square. We write this equation u is equal to minus gmm by r plus gm by r square into mh. चूंकि gm by r square is equal to small g, acceleration due to gravity, so we may write u is equal to minus gmm by r plus mgh. By convention, this is the potential energy above the earth surface at height h. This is the potential. Since by convention the gravitational potential on the earth surface is taken 0, है ना? By convention the gravitational potential energy on earth surface is taken 0. So this equation becomes u is equal to mgh. Is it clear? So the gravitational potential above the earth surface at height h, u is equal to mgh. It clear? Here we have derived the three formula. First, gravitational potential equal to minus gm by r. Gravitational potential energy we have also derived. This is the V is equal to, or this is the U is equal to minus gm by r. Gravitational potential energy at height h is equal to mgh. यहाँ हमने तीन जो है इक्वेशन डिराइव किया. Here now we have to find out the work done to raising a body from earth surface to a certain height. Large height. We can just say the large height. What will be the work done to raising a body from earth surface up है ना to a large height? ठीक है. Work done in raising a body from earth surface to a large height. कितना वर्क डन करना पड़ेगा? तो वी हैव already know the work done, that is the potential energy on the earth surface. Potential energy, gravitational potential energy on earth surface ठीक है, U बराबर, ठीक है, माइनस GM/R. और दूसरा आपने देखा ग्रेविटेशनल पोटेंशियल एनर्जी एट हाइट H फ्रॉम अर्थ सरफेस बराबर, जैसे इसको हम U1 मान लें तो और इसको U2 मान लें तो माइनस GM/R plus H. Is it clear? So what will be the work done to raising that body from earth surface to height H? So the work done बराबर U2 minus U1, that is minus GM/R plus H minus GM/R. तो ये हो गया आपका GM/R, ये प्लस हो जाएगा माइनस GM/R plus H. तो यहाँ GM कॉमन हो जाएगा, 1/R माइनस 1/R प्लस H. ठीक है, तो हो गया. सॉल्व करें तो GM/R प्लस H माइनस R बटा R इंटू R प्लस H. ठीक है, बराबर हो गया GM, ये R कैंसिल हो गया तो H बाई है ना R स्क्वायर प्लस RH, इसे मल्टीप्लाई कर दिया. अब हम इसको इससे मल्टीप्लाई कर देते हैं तो बराबर GM/H बाई R स्क्वायर प्लस RH. नाउ GM/H R स्क्वायर कॉमन ले लें तो 1 प्लस H बाई R. ठीक है, ये आएगा. तो हम जानते हैं GM बाई R स्क्वायर इंटू MH बाई 1 प्लस H बाई R. वी में राइट H. GM by R square is equal to acceleration due to ग्रेविटी, चूंकि Gm/r² इक्वल टू स्मॉल g। सो ई में राइट, तो g हो गया है वैल्यू, तो हम लिख सकते हैं mgh/1 प्लस h/r। दिस इज द वर्क डन इन रेजिंग। इफ h बराबर r हो जाए तब यह क्या होगा? इफ h बराबर r, then it becomes the 1. h/r is the 1, then it becomes w बराबर mgh/2। तो 1 प्लस 1 इक्वल टू 2। तो वर्क डन जो होगा वह mgh/2। इक्वल क्लियर, mgh/2। r² कॉमन लिया यहाँ पर, RH इधर h, okay, thank you. This is the work done in raising a body from Earth's surface to a large height. It's clear? In the next, I will talk about the escape velocity and some other topics. Thanks.